Hello and welcome, sleepy thinkers, cosmic dreamers, and wandering minds. You've arrived at Sleepy Science Story, your quiet corner of the universe, where space becomes soft and science becomes something you can drift off to. Tonight, we're going to glide gently into the tale of a stranger from the stars. Not a planet, not a comet, not quite anything we've ever seen. Its name is 3I Atlas, a visitor from another solar system, slipping silently through ours with a grace that defies understanding. I do hope this story isn't so interesting it keeps you awake, but if it does, at least you'll be dreaming among the stars. If you enjoy these quiet cosmic journeys, a gentle like and a sleepy little tap on subscribe would mean the world. Far beyond the planets we know and the quiet familiarity of our solar system, beyond the orbit of Neptune where sunlight fades into whispers, there are regions of space so dark and cold that even time seems to slow down. It was from somewhere in that distant, unknowable beyond that a traveler began to glide toward us. Not in a hurry, not with fanfare or fire, but with the unbothered grace of something ancient and uncertain. At first, it was nothing more than a subtle wobble in the data. Just a point of light that didn't quite behave like the others. It shifted too quickly, then too slowly. It cut across the usual currents, as if the familiar gravity of our sun was only a polite suggestion, not a rule. The object was moving too fast, too free, and too strangely to have been born in the embrace of our solar neighborhood. When astronomers realized what they were seeing, a hush seemed to fall across observatories. Something was coming, not from the asteroid belt or the scattered disk, but from outside everything. It had no looping orbit to trace back to Jupiter, no icy shell that matched the fingerprints of Oort cloud comets. It wasn't part of the slow solar family that spins and circles and returns. This one came from elsewhere, a true interstellar visitor, only the third one we've ever found. They gave it a simple, sleepy name, 3I Atlas, the third interstellar object ever identified. And like a whisper on the wind, it was already slipping past. To imagine where it came from is to imagine places without names. Perhaps it was flung from a newborn system when two giant planets passed too close. Or maybe it's older than Earth, drifting across the galaxy for millions or even billions of years before brushing against our awareness for the briefest moment. We don't know if it passed near a star in its youth, or if it wandered the cold between galaxies for most of its life. What we do know is that it arrived silently, like a pebble skipping across the black pond of space, tracing a path that would never repeat. Looking at its trajectory is like watching a dream slowly unfold across the sky. It doesn't loop, it doesn't stay. It enters our space, curves gently past the sun, and then continues on, never to return. In a way, it reminds us that we are not a closed system. That our solar system, for all its order and rhythm, is part of something larger and quieter and stranger, that sometimes things wander in, not to disrupt or change us, just to be seen, just to pass through. For now, 3I Atlas is still drifting nearby, though nearby in space means far beyond what even the most powerful backyard telescope could ever glimpse. But it was here for a moment, and sometimes that's more than enough. When astronomers say something is interstellar, they are describing a traveler that does not belong to our solar family. Every comet, asteroid, and speck of dust orbiting the sun follows a shared rhythm, circling in graceful obedience to the same center of gravity. But sometimes, in the slow and patient work of watching the sky, they find a wanderer that doesn't move the way it should. It cuts through the orbits of the planets at an odd angle. It travels too quickly for the sun to keep hold of it. Its path doesn't loop back but stretches open like a thread disappearing into the dark. That is when astronomers know they have found something different. Something that came from somewhere else entirely. For an object to be truly interstellar, it must be free of the sun's gravity. It cannot be bound to our star by any invisible tether. If you could trace its journey backward, the line would not circle home but drift endlessly toward the outer reaches of the galaxy. Its speed is another clue. Most of our solar objects move with a steady calm, shaped by billions of years of balance. But an interstellar traveler arrives faster, as though it has fallen for so long that nothing can slow it. The sun bends its path slightly, like a finger brushing against a ribbon in the wind, yet the visitor continues on, unclaimed and unharmed. When the first interstellar object, Oumuamua, arrived, scientists learned to recognize the signs. Its motion could not be explained by any known orbit. Its acceleration, faint but real, hinted at a life spent elsewhere. Since then, astronomers have watched carefully, scanning the quiet background of stars for other wanderers who might drift through our cosmic neighborhood. And then, one day, a faint flicker appeared in the data once again, a strange object moving faster than any comet should. 3I Atlas had entered the story. To most people, these discoveries happen silently. No alarms, no bright streak across the night sky, no sign to mark the moment something from another world slips near ours. Yet somewhere, in the dim hum of computer screens and quiet observatories, a small thrill ripples through the scientists who notice it. For them, the sky is not just a ceiling of stars, it is a living, breathing history of movement and time. Every new discovery feels like an unexpected letter from far away. To call something interstellar is to recognize its freedom. It means admitting that our solar system is not the only stage where the universe performs its quiet plays. These visitors remind us that our sun is just one light among billions, and that the space between those lights is not empty but full of wanderers whose stories we barely glimpse. 3I Atlas is one of those fleeting stories. It arrived without ceremony and will leave without farewell. Yet for a brief moment it crossed our path, and in doing so, it reminded us that even in the endless stillness of space, something is always moving. The name 3I Atlas might not stir the imagination at first. It sounds like something written in a dusty logbook or coded into a datasheet. But names in astronomy often hold quiet layers of meaning. The 3I tells us this is only the third object ever officially recognized as interstellar, joining a list so short it could fit in the palm of your hand. The Atlas comes from the observatory that spotted it first, a set of robotic eyes always scanning the skies for anything that moves when it should not. And though the name is simple, the path this object takes is anything but. Most objects in our solar system move in elegant ovals. These ellipses are the natural outcome of gravity's pull. A comet might swing in close to the sun and then drift far out again, but always with a rhythm, always with a pattern. Even when stretched to the edge of space, their paths loop back. But when Atlas was plotted on the sky, the line it traced looked different. It did not loop, it did not turn. It curved gently as it passed the sun, and then continued on its way, as if the sun were a warm lamp it briefly visited, not a force that could hold it forever. To see such a path is to feel, in some small way, the shape of freedom. Atlas moves like a ghost across the solar stage, appearing without warning and promising no return. There is a kind of loneliness in that motion, a soft reminder that not everything circles back. Sometimes, things arrive, reveal themselves for a breath of time, and slip away again, unchanged and untethered. There's something else about the path of Atlas that captures the attention of those who follow its movement. It tilts. Not wildly, but enough to feel a little out of place. Its angle across the solar system does not match the neat alignment of the planetary orbits. It slices through that invisible disk like a ship crossing the tide at a strange slant. This angle, this misalignment, is part of what first hinted that Atlas was not from here. It is like a note out of key in an otherwise familiar tune. Not unpleasant, but clearly foreign. Though its name is practical, many who study it feel something more poetic beneath the label. Some call it the lantern, because of how its faint light drifted into view. Others call it the stranger, because it does not speak the language of local objects. And in that simple, strange path there is something hauntingly beautiful. It reminds us that space is not just a map of destinations, but a sea of stories, Most of those stories never pass our way. Atlas did, briefly, like a silent visitor walking through a room of sleeping minds. It left no mark, just a presence, just a path. And that, somehow, feels enough to stir the imagination, even as the rest of the sky keeps on turning. Before the arrival of Atlas, the scientific world had already been touched by a different kind of mystery. In the fall of 2017, a long, thin object glided into our solar system from nowhere we could name. Its name was Oumuamua, which means a messenger from afar arriving first in Hawaiian. It had no tail, no cloud of gas, and no obvious reason for the way it moved. It rotated in a strange way, not like a spinning ball but more like a tumbling baton. As it passed, it sped up just slightly, enough to confuse the math. The usual explanations did not quite hold. People wondered. Some suggested ice beneath the surface was heating and releasing gas, pushing it forward. Others were not so sure. A few even whispered about technology, not because they believed it, but because they could not rule it out. Oumuamua left more questions than answers. By the time scientists understood it was interstellar, it was already leaving. Observatories scrambled to point their telescopes, but the moment was brief. All we could do was collect faint signals and stare at the strange shape, wishing for more time. Its light faded, its trail vanished, it was gone. And yet, in going, it opened the door to a new awareness. These visitors are real. They are rare but not impossible. And if one had come, perhaps others would follow. Then came Borisov in 2019. This time, it looked more familiar, a comet, with a long tail and a bright coma. Icy, active and noisy in the way comets tend to be. But its path was wrong again. Like Oumuamua, it moved too fast and too freely to belong to our Sunday. It had come from elsewhere, from some cold and distant place beyond the stars we know. Borisov was the second interstellar object, and it brought comfort in its strangeness. At least it behaved more like something we understood. Still, its origin remained a mystery. We could guess at a region of space, but the galaxy is wide, and memory fades quickly when all you have is a trail of dust. Atlas now joins this very short list, and already it is different. It does not tumble like Oumuamua or blaze like Borisov. It drifts. It hesitates. Its light is faint, and its structure uncertain. Some think it is fragmenting, others are not sure it ever held together. What is clear is that each interstellar visitor seems to speak its own language. They do not follow the same rules. They do not arrive with clear answers. They appear, pass through, and leave behind only data, questions, and the feeling that we have missed something just barely out of reach. Oumuamua taught us to look closer. Borisov taught us to expect the unexpected. Atlas, in its quiet way, is teaching us something else. That even the things we cannot understand can still offer wonder, that not every story must end in explanation, and that sometimes a passing shadow is enough to stir the still waters of human curiosity. The discovery of Atlas began, as many such discoveries do, with a quiet flicker in a stream of numbers. Somewhere in Hawaii, on the gentle slopes of a volcanic mountain, the Atlas survey was watching the night sky with its usual calm precision. The survey, which stands for Asteroid Terrestrial Impact Last Alert System, scans the heavens not for beauty but for danger. It is designed to catch things that move suddenly and might be heading our way, but sometimes it sees something that is not a threat, just a curiosity. That is how Atlas entered the story. The object appeared first as a faint moving point of light. At first glance, there was nothing particularly special about it. It looked like a small comet or a dim asteroid, one of thousands that drift through our solar system unnoticed. But as the days passed and its motion was tracked, a pattern began to form. The line it traced across the sky did not curve inward like most comets pulled in by the sun's gravity. Instead, it followed a strange open arc, cutting across the familiar paths of the planets with quiet confidence. Its speed was wrong for anything local. It was too fast to be bound, too straight to be staying. Astronomers watching the data felt that old flicker of curiosity. They checked and rechecked the numbers, they compared it to known orbits, and slowly, the truth began to unfold. This object, whatever it was, had come from beyond the sun's reach. It had not formed here, it was not one of ours, it was interstellar. Confirmation came in the form of more data, more observations from different places. As other telescopes turned their gaze toward the object, they saw the same pattern. The object was moving on a hyperbolic path, one that would carry it into the solar system and then away again forever. Its brightness flickered slightly. A soft tail began to emerge. Perhaps a little ice was warming and escaping into space, but it was faint, not dramatic like most comets, just enough to catch the light and mark it as something that was changing, even if only a little. They named it 3I Atlas, the third interstellar object, and from that moment, it became the subject of quiet excitement in astronomy circles. Observatories coordinated their efforts. Time was scheduled, images were taken. Each new observation added another piece to the picture, though the picture remained blurry in places. This was not an easy object to study. It was small, faint, and fast. Like a bird seen in the corner of the eye, it was there and then not. But it had arrived. That alone was cause for wonder. The discovery of Atlas was not marked by headlines or breaking news. It came in through the side door of the universe, gently, unannounced. But for those who watched the sky carefully, it was a moment of quiet celebration, a reminder that the universe is still full of surprises, and that sometimes, something from very far away can find its way briefly into our light. The path of 3I Atlas is not the kind that settles into memory easily. It does not behave like a comet tracing a long loop around the sun, nor like an asteroid wandering cautiously between planets. Its movement is more like a gentle arc, drawn with a soft pencil across the deep canvas of the sky, the kind of line you might draw absent-mindedly while listening to a quiet song. It begins far outside the reach of the planets, sweeps inward as if deciding whether to stay, then curves ever so slightly before continuing outward again, untouched and unclaimed. When plotted on a graph, Atlas's path stretches into what is called a hyperbola. It is not an ellipse, not a circle, not a spiral. A hyperbola means it does not belong. It enters, it bends, it leaves. There is no return trip, no looping back. That small detail changes everything. Most objects that visit the inner solar system do so on borrowed time. Comets pulled in from the outer reaches might take thousands of years to circle back, but they are still part of the solar rhythm. They are bound by gravity. Atlas is not. It has never been tethered to the Sunday. It only passed close enough for us to notice it. As Atlas moves through the solar system, it reacts to gravity the same way all objects do. The sun pulls on it, the planets tug at it. But these forces are whispers, not commands. Atlas answers with a quiet curve, a polite lean in its trajectory, and then continues on its way. It is as though the solar system reached out a hand, and Atlas gave it a brief nod before stepping past. This kind of motion gives astronomers chills, not because it is frightening, but because it is rare, it is elegant, and it is clear. The trajectory also tells us about where Atlas came from and where it is going. When scientists trace its motion backward, they find that its path came from the general direction of the constellation Hercules. But Hercules is a big place, and space is not like a roadmap. There are no clear trails leading from one star to another. Over millions of years, even a small gravitational push can shift a rock's path by light years. So we can only say that Atlas came from somewhere out there. Perhaps from a planetary system long gone, or one still forming, or from the wide, empty places in between. The way Atlas moves reminds us how much space lies between stars. It has traveled for so long, untouched by any world, seen only now by accident and patience. Its curve through our solar system is not dramatic, not showy. It is graceful, quiet, a soft signature of a stranger just passing through. And in that quietness, It tells us something deep about the universe. That even the rarest visitors can leave behind a path worth watching, a line worth remembering, a story told in motion rather than words. When scientists first saw Atlas, they asked a familiar question. Was it a comet or was it an asteroid? It is a simple question, one that helps guide how we study an object. Comets are usually icy, full of frozen gases that vaporize and create glowing tails when warmed by the Sunday. Asteroids, by contrast, are rockier, drier, quieter. They often move without much flare, reflecting only a little light, content to be seen as small stars that never twinkle. But Atlas did not fit easily into either category. It showed hints of a tail, faint and barely there, as though it were trying to act like a comet but had forgotten how. Its brightness changed slowly over time, which is often a sign of a comet shedding gas and dust. But the changes were mild, and sometimes they paused altogether. If Atlas was a comet, it was a tired one, or maybe a cautious one. If it was an asteroid, it was one with secrets hidden beneath its surface. It seemed to exist in a space between categories, borrowing a little from each but never fully committing to either. This uncertainty gave rise to more questions. What is it made of? Why does it behave so gently when others flare and burn as they pass near the sun? Was it always like this, or has it changed on its long journey across the stars? In recent years, astronomers have come to realize that the line between comets and asteroids is not as sharp as once believed. Some objects blur the distinction. There are comets that look like asteroids, and asteroids that surprise us by acting like comets. These boundary crosses are reminders that space does not always care about our labels. It is more complex than that. Atlas may be one of these in-betweeners. It might have started as a comet, rich in frozen materials, but after countless years drifting in the cold, much of that ice could have been lost. What remains is a dusty, fragile shell, still holding on to a bit of its past but unable to fully reveal it. Or perhaps Atlas was always this way. Maybe it formed in a distant system where the line between rock and ice was drawn differently. In another star's light, in another disk of material, maybe it took shape with just enough of both to remain mysterious. Its behavior now could be a soft echo of that alien beginning. What we see is only the surface. A surface that reflects just enough light to catch our attention, but not enough to tell us everything we want to know. So we watch and wonder. Not everything needs a final answer. Sometimes, the value of a mystery lies in the space it opens within us. A chance to imagine. A reason to look closer. Atlas may not be a comet. It may not be an asteroid. It may be something that lives in the quiet valley between names. And that, in its own gentle way, makes it all the more beautiful. In the quiet of April 2024, long after most eyes had stopped looking, Atlas did something unexpected. It began to come apart. Not in a dramatic explosion, not in a flare of light, but in a slow and delicate way. Small fragments began to drift away from the main body, like petals separating from a tired flower. The process was subtle. It took careful watching to even notice. But the data told the story. Brightness patterns shifted. Movements became uneven. Something was changing deep within this visitor from another star. Fragmentation in comets is not uncommon. They are often fragile, made of loosely held material that has spent most of its life in deep cold. When such an object comes near a star, the warmth begins to stir the ice. Gases expand, pressure builds inside, cracks form where sunlight reaches deeper than it should. Sometimes the structure holds, sometimes it gives way. For Atlas, something must have changed inside, a weakness revealed, a stress too long ignored. And with that, it began to shed its own pieces, not as a disaster, but as a quiet unraveling. Some astronomers think Atlas was never whole to begin with, that perhaps it arrived already fractured, held together by a delicate balance of temperature and time. Its long journey across the galaxy may have taken a toll. Invisible collisions with dust, the slow erosion of cosmic rays. By the time it neared the sun, it may have already been on the verge of letting go. The solar warmth was just the final nudge, a sigh of gravity and heat that gently pulled it apart. The fragments themselves are small, difficult to track. They scatter slightly, trailing behind the main body like shadows of what once was. Each one follows a slightly different path, drifting softly through the void. It is unlikely any will reach Earth. Most will continue onward, fading with distance, becoming part of the cosmic dust that fills the space between stars. But for a time, they move together. A final procession, silent and slow. There is a strange kind of beauty in this breaking. It is not violent, it is not loud. It feels more like a kind of release, a quiet transformation rather than a failure. To fall apart is not always to end. Sometimes it is to become something new. Atlas in breaking becomes easier to study. Each piece reflects light in its own way. Each shift in motion tells scientists a little more about what lies beneath the surface. What begins as a mystery grows into a mosaic, and we, watching from so far away, gain a clearer view of what was once hidden. So as Atlas continues its journey, a little less whole than before, we see not the loss but the unfolding. A visitor that came from the stars passed through our sky and left behind pieces of itself in the most delicate farewell. Not a collapse, but a quiet scattering. Not an ending, but a softer kind of continuation. When something breaks apart in space, the reasons are not always clear. From far away, all we see are the aftereffects. A change in brightness, a shift in movement, a scattering of smaller shapes where once there was one. But if we try to imagine what is happening up close, we begin to see a different kind of story. One not of violence, but of quiet pressures that slowly build over time. The kind of pressures that wear down even the most silent travelers. For Atlas, its journey into the inner solar system meant exposure to light and warmth it may not have felt for millions of years. If it was ever cold enough to be held together by frozen gases, those would begin to soften as sunlight reached them. What was once solid and still could start to shift. Gases trapped inside might expand. Pockets of volatile material could awaken and search for a way out. And if the structure of the object is fragile, even a gentle warming might be enough to start a crack that deepens with every passing hour. There is also the quiet force of gravity to consider. As Atlas moved closer to the Sun, it began to feel a stronger pull. Not just from the Sun itself, but from the large planets it passed near. These gravitational fields tugged at it in slightly different ways. One side might feel a slightly stronger pull than the other. Over time, that small difference adds up. It is called tidal stress, the same kind of force that causes ocean tides on Earth, except here, it works on rocks and ice and dust. If the object is not solid all the way through, if it has cracks or hollow areas, the stress can begin to open it up. Not suddenly, not with a bang, but gradually. A stretching that leads, eventually, to separation. Sometimes, even the shape of the object plays a role. If Atlas was spinning, even slowly, the rotation could have put uneven pressure on its surface. Over time, those small shifts in balance can make a difference. Imagine a sculpture of packed snow slowly turning in the sunday. One side warms faster, one side becomes thinner. And eventually, it begins to fall apart in soft, quiet pieces. In space, nothing happens quickly unless pushed. Atlas was not pushed. It was gently encouraged, warmed, tugged, tilted. And in the end, it responded by coming apart. Not because it was weak, but because it was ready. Because it had held together long enough. Because its structure was always temporary, like a sandcastle that knows the tide will come. These small breakings are not failures. They are part of a larger journey. They reveal what lies beneath. They offer us a glimpse into materials and shapes and histories we cannot otherwise touch. Atlas, in falling to pieces, becomes more understandable. And in that soft collapse, it offers one last gift. A chance to learn more from what was hidden, now gently revealed. From the moment it entered our view, Atlas has been a quiet riddle. Most comets announce their presence with a sudden bloom of light, their icy surfaces warmed by the sun until jets of gas and dust burst into space. They shimmer and glow, leaving bright tails like strokes of a cosmic paintbrush. Atlas, however, remains soft-spoken. Its brightness fluctuated gently, never flaring, never truly dimming. The little tail it displayed was barely visible, like mist trailing behind a distant ship. Some nights, it was almost invisible. Other nights, it shimmered faintly like a candle struggling to stay lit in the dark. This behavior left many wondering, was Atlas a dying comet, one that had lost its volatile heart long ago? Or was it simply old and exhausted from its long journey between the stars? Perhaps it had never been full of gas and ice. Perhaps its materials were always quiet, never meant to erupt or shine. If it had once been active, it may have used up much of its energy before it reached our solar system. Long years spent drifting through cold, empty space can wear a body down in ways we can only guess. Micrometeoroid impacts, the constant buzz of cosmic rays, flee. Even the smallest forces can have slow, steady effects over millions of years. Some scientists believe Atlas is still active, just at a very low level, like an ember rather than a flame. Tiny amounts of gas might still be escaping from its surface, carrying with them small particles of dust. These would reflect sunlight and create the faint tail we see, even if the process is barely underway. But without a strong outgassing, the comet remains quiet, unassuming. It whispers rather than sings. Others suspect that Atlas is already breaking apart, and the strange behavior is not activity but decay. Pieces of its surface might be flaking off, exposing darker material underneath. That could change the way light reflects off of it, making it seem like the object is flickering. If its fragments are slowly separating, that too could confuse our observations. We might not be looking at one object anymore, but several, all moving close together, each changing in its own small way. This uncertainty is part of what makes Atlas so interesting. Most comets follow patterns, they behave in ways we have come to expect, but Atlas breaks the rhythm. It moves more slowly, it brightens with hesitation, it fades with reluctance, it holds back just enough to keep us watching, and in that restraint, there is a kind of beauty. Not all visitors from space need to dazzle us. Some simply pass through, quiet and complex, leaving behind not a trail of answers but a soft invitation to wonder. Whatever its nature, Atlas carries itself with calm. It may be active, it may be fading, it may be something in between. But it remains, for now, a gentle presence in the sky, a steady stranger, with nothing to prove, and sometimes that is enough. Far above the noise of cities and the hum of human life, the sky is always being watched. Telescopes sit quietly on mountaintops, orbit in the stillness of space, or drift in distant deserts far from streetlights. These instruments do not sleep. They wait patiently for the darkness to return, for the stars to rise, and for the quiet signs of change to appear. When 3i Atlas came into view, they turned their gaze. Not with alarm or excitement, but with the calm curiosity that defines so much of astronomy. A new visitor had arrived, and it was time to listen. The Vera C. Rubin Observatory, though still in preparation, represented the future of skywatching. Its planned surveys promised to catch movements like Atlas, with stunning regularity, capturing the entire visible sky every few nights. Other observatories, already operating, stepped in to follow Atlas's path. The Hubble Space Telescope, orbiting far above the Earth's blur of atmosphere, was given a chance to peer at the interstellar traveler. Its vision, sharp and steady, could capture the faintest changes in shape and brightness. The James Webb Telescope, more tuned to infrared and deep cosmic history, was better suited for the early universe than visiting rocks, but still held promise for observations if time and alignment allowed. Closer to the ground, smaller observatories joined the watch. Their lenses recorded images over hours and nights, building layers of data like brushstrokes in a slow-moving painting. Each image was a conversation with a piece of the cosmos. Atlas responded not in words but in light, a change in brightness, a soft tail that drifted slightly to one side, a flicker that did not match the time before. Radio telescopes listened as well, not expecting words, of course, but rather the silence of the object itself. They searched for signals, not from the object but around it. They watched for reflections, distortions, anything unusual. What they found was mostly the stillness of deep space. But sometimes, silence is a kind of answer too. From the beginning, the instruments treated Atlas with care. Time on a telescope is precious. Observatories plan their viewing schedules months or even years in advance. For Atlas, time was made. Adjustments were arranged. Observers gave up other studies to catch a glimpse of something so rare, the third interstellar object ever found. The chance to see one up close, even if only briefly, was too precious to ignore. All of this effort built a quiet web of attention around Atlas. Data streamed in from different continents and orbits. Charts were made. Models were tested. Not all the answers came quickly. Some may never come at all. But the process itself, this careful watching, this slow unraveling of mystery was its own kind of reward. Scientists and sky watchers alike stood together in that patient silence, watching a stranger pass through, knowing it would never return, and finding beauty in the act of seeing. Not every guest must stay long to be remembered. Some just need to be noticed. After months of quiet observation, a picture of Atlas began to form, though it remained more impressionistic than clear. Scientists had watched its brightness flicker gently over time, had seen the subtle trail of dust that hinted at some level of activity, and had measured the curve of its motion with care. The data gathered spoke in soft tones, and the story it told was not loud or dramatic, but full of nuance and quiet wonder. One of the first things researchers noticed was its low density. This did not come as a shock. Many comets and small interstellar visitors are not solid stones but rather loose collections of material. Atlas seemed to fit that mold. It was likely porous, filled with empty space between grains of dust and ice, held together not by strength but by ancient stillness. A structure like that can survive the cold of deep space for millions of years, but near a star, even a little warmth can start to unravel it. The light it reflected was another clue. Its surface did not gleam like metal or ice. It was dull, more like ash or soot. This suggested that much of its surface had been weathered by time and radiation, perhaps covered by a dark coating of cosmic dust collected over a long journey. This kind of surface does not reflect much sunlight, which explained why Atlas remained so faint even when it passed relatively close to the inner solar system. There were signs that parts of it may have broken off. A few faint trails appeared to drift alongside it, consistent with small fragments peeling away. These fragments were not fast or explosive. They drifted slowly, like bits of thread caught in a breeze. The lack of dramatic motion supported the idea that Atlas was not an energetic comet, just a fragile traveler beginning to show its age. Spectral readings offered another layer of insight. Scientists used light filters to try and detect the chemical signatures of the gases and materials being released, if any. What they found was minimal. The usual signs of water vapor, carbon dioxide, or other frozen volatiles were weak or missing. If Atlas had any remaining ice, it was either too deep to reach the surface or too little to make much difference. This aligned with the idea that it was either old and dried out, or never very icy to begin with. Altogether, these findings did not solve the mystery of Atlas, but they softened its edges. Instead of one big question, scientists now held a handful of smaller, more detailed ones. The object was fragile, its brightness was modest, its chemistry was quiet, its motion confirmed it came from another star. None of this answered the bigger question of what exactly Atlas was, but it gave shape to the mystery. It made the unknown feel more familiar. In the end, perhaps that is all we can hope for, to turn the distant and strange into something just close enough to wonder about, to bring a shape to the silence, to understand, if only in part, what passes by in the night. Every now and then, in the quiet space where science meets imagination, a question drifts in that feels just a little too bold to say out loud. With 3i Atlas, one of those questions has begun to echo softly in a few corners of conversation. Could it be artificial? Not in the dramatic science fiction way of glowing metal and humming engines, but in a subtler, stranger way. Could something about its shape or motion suggest design rather than accident? Could this visitor be more than it appears? For most scientists, the answer is a gentle but confident no. The data so far shows nothing that demands an extraordinary explanation. Its speed, while fast, is expected for something falling in from interstellar space. Its faint activity is consistent with a fragile comet or a rocky body slowly shedding dust. Its path follows the expected curve of gravity. Still, the question lingers, not as a declaration, but as a whisper of possibility. A reminder that when something comes from beyond our solar system, it enters not just our telescopes, but also our dreams. The idea that Atlas might be artificial did not come from wild claims or viral headlines. It began with Oumuamua, the first interstellar object ever observed, which behaved in ways that left scientists scratching their heads. It tumbled strangely, accelerated without a clear cause, and had no visible tail. That mystery inspired some to ask whether it could have been something more, perhaps a kind of probe or abandoned fragment of alien technology. The idea was not widely accepted, but it opened a door. It made people look at future visitors, like Atlas, with more curiosity and perhaps a little more imagination. With Atlas, there has been no unusual acceleration, no sharp turns, no radio signals. It is far more subtle than Oumuamua, far less attention-seeking, if such a thing could be said of rocks and dust. And yet, because we do not know where it came from, and because we cannot see it up close, the unknown wraps itself gently around the edges of what we do know. Could its quiet behavior be intentional? Could its structure hide more than it reveals? The odds are almost certainly low. Space is full of strange things that can be explained by physics and time. Most of them never raise any eyebrows. But the very act of asking the question speaks to something human. We long to know if we are alone. We wonder whether the stars hold more than light. When something drifts in from out there, silent and slow, we cannot help but lean in a little closer, just in case. In the end, Atlas is most likely just what it seems. A fragment of some forgotten system, shaped by cold, pulled by gravity, and passing by unnoticed for ages until now. But maybe, just maybe, the quietest visitors are the ones that leave the loudest questions. And even if Atlas tells us nothing more, it has already reminded us how wide our imagination can stretch. Across the wide, quiet plains of the Earth, and in orbits high above its surface, radio telescopes turn slowly, scanning the dark for the faintest whispers. These great dishes of metal do not seek out music or words, at least not in the way we usually think of them. They are built to listen for energy, for the invisible signals that might drift across the stars, carrying the soft hum of galaxies or the static of a supernova. And once in a while they aim their long ears towards something more specific. When Atlas arrived, some of those ears turned in its direction, not because anyone truly expected to hear anything, but because it felt like the right thing to do. Listening for signals from an interstellar object is a delicate art. There is so much background noise. The universe is always singing, if you know how to listen. The cosmic microwave background hums quietly in every direction. Pulsars send out regular beats like the ticking of a giant clock. The sun adds its own chatter, especially when it flares. Earth itself contributes plenty of interference. From satellites to phone towers, the air is full of human-made sound. But within all that noise, there is always the hope that something unfamiliar might appear. A pattern, a burst, a rhythm that does not belong to any known object. For Atlas, the results were quiet. No signals, no beacons, no pulses or pings. It passed through the range of many observatories and left behind the same silence it had arrived with. But that silence has meaning too. It confirms that, at least in the frequencies we searched, Atlas was as quiet as any natural body would be. It behaved like a fragment of rock and dust, a cold traveler with nothing to say. For most scientists, this was expected. But even in the stillness, there is value. Science is not only about surprise, it is also about confirmation, about building the map of what is, piece by piece. Some might wonder why we even bothered to listen. If the odds of a signal are so low, why spend precious hours pointing radio dishes at a lump of rock? The answer lies in our curiosity, in our hope, in the understanding that great discoveries sometimes come from small, quiet efforts. If we had not listened, and a signal had been there, it would have been lost forever. Instead, we listened, we recorded, and we added Atlas to the growing list of interstellar visitors who pass silently through our lives. The silence from Atlas may be complete, but it is not empty. It is the same kind of silence we hear from the moon, from Mars, from ancient comets that circle the sun without comment. These silences are not disappointing. They are part of the universe's rhythm. Atlas has given us one more gentle moment in that great symphony of quiet, and sometimes it is in the silence that we learn to hear the most. Gravity is often imagined as a force of immense power, bending the very fabric of space and holding entire planets in their long orbits. It is a mighty presence, yes, but it is also subtle. It works slowly, it pulls without haste. For an object like Atlas, entering our solar system from the great dark beyond, gravity's touch was light but steady. As soon as it neared, the sun began to bend its path, curving it gently inward. Not enough to trap it, not enough to keep it, but just enough to turn its journey into an arc rather than a line. Celestial mechanics is the name we give to the dance of these movements. The rules are ancient and beautiful. Newton helped us see how all things fall toward one another, how a planet can orbit a star in a perfect balance of motion and pull. Atlas does not orbit, it falls past. But even in that brief encounter, it follows the same rules. The same laws that guide Jupiter and Neptune also shape the glide of a lonely visitor. As Atlas curved through the solar system, it obeyed these laws perfectly. Its speed and trajectory told scientists everything they needed to know. It was not bound. It would not loop back. Once past the sun, it would continue outward, slipping into the shadows once more. But in that short visit, the solar system gave it a kind of signature, a small twist in its path, a change in speed. These changes allow astronomers to calculate where it might go next, and to imagine where it might have come from. There is a kind of elegance in watching gravity at work. It does not need to be seen to be understood. The math describes the story with incredible precision. An object like Atlas moves along a hyperbolic path, shaped by its original speed and the gentle curve of the sun's pull. It is like a dancer moving through a crowded room, brushing past others without ever stopping, its motion guided not by choice, but by the invisible layout of space itself. Even when Atlas was too faint to see clearly, its position could be predicted. The equations worked every time. That quiet reliability is what makes celestial mechanics feel almost comforting. It tells us that in a universe full of uncertainty, some things still move in ways we can trust. Even an object from another star, born in a place we will never see, still follows these same patient rules. Atlas may be mysterious in many ways. Its structure, its origin, its behavior may remain unclear, but in its motion, it is honest. It is a perfect example of how the universe holds itself together with grace and balance. It falls, it curves, and it moves on. All of it written in the quiet language of physics. All of it part of the great, slow rhythm that carries everything from pebbles to planets through the endless dark. When astronomers try to trace the path of an object like Atlas back through space, they begin with numbers. They take its speed, direction, angle, and the pull of the sun, and they work backwards. In theory, this should show where it came from. But with interstellar objects, that journey becomes more difficult the farther you look. Space is not an empty stage where objects move in straight lines. It is a shifting sea, full of gravity wells and drifting dust, where even the smallest tug can change a course completely over time. And Atlas, it seems, has been traveling for a very long while. The best we can say is that Atlas entered our solar system from the general direction of the Hercules constellation. That is a wide area of sky, filled with countless stars and dust clouds. Somewhere within that view, perhaps long ago, something happened that sent Atlas on its way. Maybe it was flung by a passing planet in a system now lost to time. Or maybe it was never part of a system at all, but formed quietly in the cold outer edges of a newborn star and was pushed out before it had a chance to settle into orbit. We do not know the truth, and we may never. Because Atlas does not carry a label or a return address, we are left with only gentle guesses. The galaxy is a place of constant motion. Stars orbit the galactic center, some fast and some slow. Clouds of gas stretch and drift. Planets form and vanish. All of this means that trying to reverse engineer the path of a single fragment through this cosmic flow is like trying to trace a single snowflake back to the cloud that made it. The farther back you look, the less clear it becomes. What we do know is that Atlas has likely traveled for millions, if not billions of years. That distance gives it a kind of quiet dignity. It has seen places we will never know. It has passed stars that blinked out long before Earth was born. It has moved through regions of space so dark and still that nothing ever stirs. And now, for a brief moment, it passed near us. Not close enough to touch, not long enough to study deeply, but close enough to see. There is a certain humility in knowing that we cannot follow its trail completely. It reminds us how wide and unknowable the galaxy truly is. We want to know the full story, of course. We want to picture the star that warmed it once, or the planet that may have nudged it free. But instead, we are left with a single chapter. The one where it passed through our sky. The rest remains hidden, written in the gravity of distant systems and the silence between stars. In that mystery there is wonder. Atlas came from somewhere far beyond our maps, and it will return to that vastness. And though we may never know the full journey, we were here for a moment of it. That is enough to leave a quiet mark on our memory. When something comes from another star, it brings with it a kind of quiet potential. Even a small fragment like Atlas may carry within it the story of another world. It might be a broken piece of a planetesimal, one of the early building blocks of a solar system. It might have formed around a different star entirely, under conditions we can only imagine. And in that possibility, there is a soft hope that it could carry secrets that no object from our solar system could ever tell. If we could reach Atlas, if we could gather even the smallest grain from its surface, we might learn something entirely new. The chemical makeup of its rock or dust could be slightly different. The balance of elements might tell us what kind of star once warmed it, or what kind of environment shaped it. There might be isotopes in unusual ratios. There might be minerals we have never seen. Even a single particle could offer a window into a system that no longer exists. We know that comets and asteroids within our own solar system contain valuable records of the past. They preserve ice and dust from the time of the sun's birth. They are like time capsules, untouched by much of the change that shaped the planets. Atlas could be the same, but for another star, another time. Perhaps even another kind of chemistry, and yet we cannot touch it. It is too fast, too distant, too temporary. It appeared suddenly and will leave just as quietly. All we can do is watch as it moves past. Still, the idea that it could carry these secrets is not lost. Scientists dream of one day capturing an interstellar object, not just observing from afar, but actually reaching it, gathering samples, returning them home. That kind of mission would take years to plan and longer to complete, but the dream has begun. Atlas may not be the one we catch, but it reminds us of why we want to try. Even now, as it slips away, the dust it sheds might drift toward us. Tiny particles, no larger than grains of sand, could eventually find their way into our atmosphere. So find could hey. If they do, and if we are watching, we might catch them as they burn. Instruments could detect their composition. We could see what they are made of. A faint signature in a meteor could hold the echo of another world. So we wonder, could Atlas carry organic molecules? Could it hold clues about how life might begin in far-off places? These are not questions with clear answers. But they are gentle possibilities. And sometimes, possibility is enough. It stirs our curiosity. It reminds us that space is not empty, but full of history drifting quietly from one place to another. Atlas may not speak, but it carries something. Maybe a piece of a forgotten system. Maybe a grain of dust older than our Sunday. And in that quiet passage, it invites us to imagine all that it might hold. The journey of Atlas is nearly over, at least from our point of view. It entered our solar system quietly, spent a short time moving through the watchful reach of our instruments, and is now continuing its long path outward. There is no spacecraft following it. No mission was sent to meet it. Its departure will be just as gentle as its arrival, a slow drift into deeper darkness, away from the sun's warmth and back into the cold that it has known for most of its existence. Already it is growing fainter. The sunlight that once caught its surface is now more distant, more angled. Its brightness, which was never bold to begin with, dims with each passing night. The curve of its path bends only slightly, shaped by the last touches of solar gravity. Soon it will slip beyond the reach of our telescopes, not because it has changed direction, but because it is simply too far and too faint to see. One day, someone may look up the coordinates and find nothing but blackness, the place where a visitor once passed and now is gone. This fading is not tragic, it is part of the story. Most things in space are not built to stay in view. Even the stars we watch each night are slowly moving. Galaxies turn. Moons drift. All of it is motion. Atlas is no different. It came close enough to be noticed, and that alone makes it special. Many interstellar objects pass through the galaxy unseen. Atlas, by chance or by grace, came close enough for us to say we were here at the same time. For scientists, this is not the end. They will continue to analyze the data it left behind. The patterns in its light, the angle of its tail, the slight variations in its path. There will be papers written, models tested. The mystery of Atlas will linger, even as the object itself recedes into the quiet. For the rest of us, the story becomes memory. We remember that once, not so long ago, something from beyond the stars passed through our skies. It did not speak, it did not change our world. But it offered a gentle kind of wonder. It reminded us that the solar system is not a closed garden. It has doors, and sometimes they open. It reminded us that space is not empty. It is full of motion, of drift, of silent visitors whose paths are long and unknowable. Soon Atlas will return to the interstellar sea, a tiny object alone again in the vastness between stars. It will not know that we watched it. It will not know that it passed through a system full of life and light and questions. But we will know. We will remember. And maybe, years from now, when another interstellar traveler appears, we will think of Atlas. Not as a mystery solved, but as a presence shared, a story we were lucky enough to glimpse before it was gone. There is a certain poetry in the idea of cosmic driftwood. Pieces of ancient systems tossed into the galactic current and left to wander without destination. They do not follow the steady orbits of planets or moons. They do not spin in place like stars. They drift, quietly, endlessly, like forgotten notes in a long, unfinished song. Atlas belongs to this family of wanderers. It is one of the few we have seen, but it is likely not alone. All across the galaxy, planetary systems are born in clouds of gas and dust. These places are full of motion and collision. Some fragments never find a place to settle. And they are nudged, pushed, or thrown by larger objects. Over time, they pick up speed and slip beyond the grasp of their parent stars. Once free, they become part of the interstellar sea. And in that sea, they drift like leaves on a wide and quiet river. Atlas is just one leaf among many. It came from a place we do not know, and it is already leaving ours behind. But knowing that it exists confirms something important. Our galaxy is not a neat collection of systems in isolation. It is a place of exchange, of movement, of quiet chaos. Objects from one system can pass through another. Bits of one world can visit another, and though these visits are rare and fleeting, they are reminders of connection across deep space. We do not yet know how common these interstellar objects truly are. They are difficult to spot. Small, dim, and fast, they slip through the solar system like shadows. But as our instruments grow more sensitive and our sky surveys become more frequent, we are starting to catch more of them. Oumuamua, Borisov, now Atlas, each one different, each one strange, each one carrying a piece of elsewhere. In a way, these objects are messages in a bottle, not written with words, but with minerals, dust, and time. They carry the stories of their origins in their structure, in their speed, in their silence. Some may come from systems that still shine, others may be all that remains of stars long gone. A quiet trail of what once was, drifting through the darkness. If Atlas is driftwood, it is not meaningless. It has shape, it has history, it has value, not because it changes us, but because it reminds us of what lies beyond. It tells us that the universe is full of stories we have not yet heard, stories that travel not with light, but with matter. With small, slow visitors that pass through and move on. Someday, we may see more of them. Perhaps we will even send a ship to greet one. But for now, we can be still and watch. Atlas has shown us that the galaxy is not empty. It is full of motion, full of pieces that do not belong to one place but to all places. And that thought alone is worth carrying with us, long after the object itself has gone. There is something deeply human about the desire to understand. When we see something new or strange, our first instinct is often to ask why. Why did it come? What is it made of? Where did it begin? With Atlas, these questions have followed its path like shadows. Since its discovery, astronomers have worked to trace its motion, measure its brightness, and guess at its structure. But in the end, many of those questions may remain unanswered. And that is not a failure, it is a lesson in letting go. Atlas is not like the planets we can revisit or the moons we can map. It is not bound to the Sunday, it will not swing back around for another look. It was seen once, watched for a short time, and now it is leaving. We can run simulations and gather data, but the chance to study it closely has already passed. There is a soft sadness in that truth, but also a quiet acceptance. Some things are meant to be observed from a distance. Some things arrive only once. Letting go of certainty is not always easy. Science often moves by building firm knowledge, by repeating experiments, by testing and proving. But not all discoveries offer that kind of clarity. Some arrive as glimpses, as suggestions. Atlas is one of those. A reminder that not every part of the universe is here for us to fully understand. Some parts just pass through, offering only a moment of presence. And yet, even in its mystery, Atlas gave us something real. It expanded our sense of what exists beyond our solar system. It confirmed that objects from other stars can reach us. It added to the quiet record of interstellar visitors. Each piece of information, however small, has value. Each new visitor helps shape a larger picture of the galaxy and its rhythms. There is comfort in that bigger view. Just as we cannot hold on to Atlas, we cannot hold on to every mystery, but we can learn to appreciate them. We can observe, we can listen, we can remember. Atlas may not answer all our questions, but it reminded us that the sky is full of passing stories. Some unfold slowly, some appear only once. Some are meant to be wondered about more than explained. The night sky has always been a place for imagination. Long before telescopes, people looked up and created meaning from what they saw. Atlas fits into that tradition. It is a question more than an answer, a presence more than a conclusion. And maybe that is what makes it special. In the end, science is not only about certainty, it is also about wonder, about letting your mind drift toward what might be. Atlas asked us to do that. To watch without needing to solve, to let go of the need to know everything. And in that letting go, we found something just as valuable, a moment of quiet awe, a reason to keep looking up. In astronomy, names often begin as numbers, strings of letters and digits that describe the order of discovery, the instrument that found the object, or its general classification. Atlas was no different. When it first appeared, it was called 3I, the third interstellar object ever confirmed. The I stands for interstellar, and the number marks its place in a very short list. The rest of the name, Atlas, comes from the observatory that spotted it, the Asteroid Terrestrial Impact Last Alert System, a set of robotic eyes constantly scanning the sky for anything that moves in unexpected ways. So the name, while informative, feels more like a filing label than a story. But names rarely stay in the realm of paperwork. The people who study these objects, who track them night after night and sketch their slow arcs across the sky, often begin to refer to them differently. They find something in the shape or the silence or the timing that invites imagination. Some called Atlas the lantern, because its light appeared suddenly and then began to fade, like a small lamp in a vast dark room. Others called it the stranger, not out of fear but out of respect, because it moved like nothing else and never stayed long enough to be known. These informal names do something important. They give personality to what might otherwise feel distant or cold. They remind us that science is still a human practice, full of wonder and emotion. Numbers help us organize the universe. Names help us feel connected to it. When a rock from another star passes through our solar system, it might seem like a small thing, but when we give it a name, we acknowledge that it matters, that we saw it, that we cared enough to notice. The tradition of naming objects after their discoverers, their instruments, or mythological figures has deep roots. Comets often carry the names of the people who first observed them. Moons and planets are named after gods and legends. In a way, these names become a form of storytelling. They turn raw data into something we can remember, something we can speak aloud beneath a starlit sky. Atlas, as a name, fits quietly into this tradition. It speaks of something that holds weight, something that carries meaning across great distances. And while this object is not holding up the heavens like the figure from myth, it is carrying something of its own, the memory of a system we will never see, the motion of a body set loose long before we were here to watch it. No matter what name we use, the meaning is the same. Atlas is not just a sequence of observations, it is a moment of connection, a bridge between our world and whatever distant place it came from. Names may not change the object, but they change how we remember it. They give shape to the story. They offer a gentle way to say goodbye. And in the case of Atlas, they let us carry the mystery just a little longer, even after it is gone. When Atlas entered the story, it was only the third of its kind. Before it, there were two others, each strange in its own way, each passing through with more mystery than clarity. The first, Oumuamua, was long and tumbling, with no tail and no clear explanation for its acceleration as it left. It was silent and puzzling, a visitor that did not match anything we expected. The second, Borisov, looked more like a traditional comet. It had a bright coma and a visible tail, full of gas and dust, and it moved like a familiar object in unfamiliar territory. Atlas arrived after both of them, and in some ways, it seemed to split the difference. Unlike Oumuamua, Atlas showed signs of activity. There was a faint tail, a suggestion of outgassing, the kind of behavior we associate with icy bodies nearing the Sunday, but it was far more fragile than Borisov. It began to fragment, slowly falling apart as it passed through our view. That quiet disintegration reminded scientists that not every object is built to last. especially when it enters a warmer, more chaotic region of space. Comparing these three gives us a glimpse into the variety of interstellar objects. They do not come in one shape or with one story. Each one is different. Oumuamua was fast and uncooperative. It offered no tale to study, no easy answers. Borisov came with the glowing energy of a typical comet, leaving a clearer trail for observers to follow. Atlas hovered between the two, showing a little of each but never quite settling into either role. These differences are not just curiosities, they are clues. They tell us that planetary systems across the galaxy may be just as diverse as the objects they send out. One system might produce dense rocky fragments. Another might cast off loose, icy bodies that crumble easily when heated. The objects we see are shaped by the conditions where they formed and the long journeys they endured. Every crack, every curve, every flicker of light carries part of that story. By studying these visitors side by side, scientists begin to ask deeper questions. Are these three typical, or are they unusual even among interstellar debris? Are we only seeing the brightest or most dramatic ones, while countless others pass through unnoticed? What tools will we need to catch the next one earlier, to study it longer, or even send a mission to meet it? Each visitor adds a layer to our understanding. None of them gave us a complete picture, but taken together, they form the beginning of something new. A kind of science that reaches beyond the borders of our solar system. A science built on brief encounters and careful comparisons. Atlas is part of that pattern now. Its gentle arc through our sky joins the paths of the others. And though it will fade, its differences and its similarities will help us prepare for whatever comes next. Because there will be more. There is still so much sky left to watch. Some science stories unfold quickly. A signal is received, an image is captured, and suddenly there are headlines and excitement and answers, but other stories move more slowly. They begin quietly, drift along for a while, and leave without much resolution. Atlas is one of those. It arrived without warning, revealed only a few of its secrets, and now slips away with most of its mystery still intact. Some might call that a disappointment, but for many, it feels like something else. A reminder that unfinished science can still be beautiful. There is something deeply comforting about a mystery that does not insist on being solved. It invites us to wonder instead of conclude. It lets the imagination stretch without snapping into certainty. Atlas gives us this gift. It does not demand that we explain it fully. It simply offers a moment of presence, a brief appearance in our skies, and a collection of quiet questions that we can carry with us for years to come. In the past, many of the greatest discoveries began this way. A strange object in the distance, a line in the sky that did not fit, a flicker on a chart that meant something more. Often it was years later before someone found the connection, the pattern, the explanation. That waiting is part of the process. It teaches patience, it teaches humility. Atlas does the same. It reminds us that knowledge does not always arrive on schedule. And so we build what we can. We gather observations, compare them with what we already know, and begin to form gentle possibilities. Maybe Atlas is a crumbling comet from a distant system. Maybe it is a fragment of something larger. Maybe it holds materials we have never seen. Each idea is a thread, not a conclusion. Each one leads somewhere, even if we do not yet know where. Unfinished stories also keep the door open for new voices. A mystery that remains can be picked up again later by someone with better tools or a fresh way of thinking. Atlas will live on in data, in papers, in quiet discussions. It may inspire new ideas about how to detect and study interstellar objects. It may influence the design of future missions. Its gentle presence may ripple forward through time, long after its light has faded from view. In this way, science is not so different from poetry. It values clarity, yes, but it also values the moment between thoughts, the pause, the question, the space where meaning is not fixed. Atlas lives in that space. It is a shape moving through darkness, a path we briefly glimpsed, a question that does not need an answer to be worth asking. Not every discovery is a solution. Some are invitations. Atlas was one. It asked us to look up, to listen closely, and to feel the wonder of something unknown. And even now, as it leaves, that invitation remains, still open, still glowing softly in the night. As we look to the future, the dream of catching an interstellar object like Atlas becomes more than just a quiet wish. It becomes a challenge, a goal whispered among scientists and engineers who imagine what it would be like to meet one of these visitors up close. Right now, all we can do is watch them as they pass through our sky. We see the light they reflect. We trace their paths. We guess at their origins. But we never touch them. We never send a spacecraft fast enough or early enough to intercept them before they disappear into the stars again. That may change. Atlas has shown us how fleeting these encounters are, but it has also shown us that they are not impossible. We know that interstellar objects exist now. We know how to recognize them. And as our telescopes become faster and our observations more precise, we may one day see one coming early enough to act. Maybe the next one will give us more time. Maybe it will be brighter. Maybe it will pass closer. And when it does, we might be ready. Scientists are already thinking about how such a mission would work. It would need to move fast, faster than any spacecraft we have launched before. It would need to be prepared long before the object is even found, sitting in orbit or on standby, ready to launch with only days or weeks of notice. It would need to be small, efficient, and smart, and it would need to survive the vast emptiness between the planets, chasing something that is already slipping away. If we did manage to catch one, the rewards could be enormous. We could analyze the surface directly, we could collect dust or gas. We could send back images not just from afar but from the very edge of the object, revealing details no telescope could ever capture. We might learn about materials that formed around other stars. We might see how different or how familiar another system's leftovers might be. And even if we cannot catch one physically, we are learning how to catch them in other ways. With better sky surveys, we can find them earlier. With more coordinated global efforts, we can study them more completely. Each visitor gives us more experience. Each one leaves behind a better understanding of how to prepare for the next. Catching an interstellar object is still in the future, but it is no longer science fiction. It is a plan slowly forming, a vision shared by those who look up and see not just the stars, but the paths between them. Atlas may not be the one we caught, but it was one of the reasons we will try. It reminded us that the universe still sends messages, still sends pieces of itself across the vast dark, and that if we are patient, if we are watching, one day we may finally reach out and hold one in our hands, even for a moment, even once. Now, as Atlas glides beyond the reach of our instruments and slips into the quiet space between the stars, we say a farewell that feels more like a thank you. Not because it gave us all the answers we wanted, but because it passed through at all, because it reminded us that we are not alone in our little corner of space. That even in the deep dark, far from the warmth of any sun, something still moves, something still arrives, something still leaves. We may never see Atlas again. Its path carries it away from the sun forever. There will be no return. It will not become a repeating name in the sky like Halley's comet. It will become memory, data, a slow arc in a chart, a faint trail of light in an old photograph. But memory has a way of lingering, and Atlas has already made its place among the stories we carry. There is something beautiful about a visitor who comes only once. Something about that rarity gives it weight. It passed by not to stay, but to be seen. For a few months, we turned our eyes to it. We measured, we wondered, we followed its gentle curve through the solar system. We imagined the system it came from. The long journey it must have taken. The forces that shaped it before we ever knew its name. And now, we imagine it still drifting, past the edge of our gravitational reach, past the orbits of Neptune and the scattered icy fragments beyond, into the true deep. A place where starlight barely reaches, and silence becomes a kind of presence. Atlas will continue there, slowly, steadily carrying with it the dust of another world and the soft imprint of our attention. It is strange in a way how something so small can stir so much feeling, how a distant object, colder than ice and dimmer than a candle, can create such a sense of connection. But maybe that is what makes space so powerful. It stretches the mind. It softens the edges of our ordinary thinking. It invites us to pause and notice, to ask questions we cannot yet answer, to dream without needing the dream to end. Atlas was a reminder that the sky is not finished, that discovery is still possible, that the universe still has surprises. And for those who watched, who read the charts and tracked the data and whispered ideas in the quiet hum of observatories, Atlas became more than an object. It became a kind of poem. A slow one, a quiet one, but a poem all the same. So we let it go. We do not chase, we do not cling. We thank it for passing through. We fold its story into our understanding and our imagination, and we keep watching. Because somewhere, another visitor may already be on the way, and when it comes, we will be ready to look up again, just as we did for Atlas, just as we always have. And so, as 3i Atlas drifts slowly back into the dark, we're left with more wonder than answers. But perhaps that's the gift it brought, not clarity, but quiet curiosity. A reminder that even in a universe full of noise and light, there are still soft questions floating gently between the stars. So rest now. Let the story of Atlas settle in your thoughts like moonlight on still water. The visitor is gone, but your imagination can follow it forever. Sleep well, and may your dreams be full of cold stars, warm mysteries, and galaxies made of whispers. Let me know in the comments where in the world you're listening from. It's always lovely imagining this sleepy story echoing across time zones.